All right, a composite figure is a figure that can be separated. Whoops, spelled separated wrong. Into regions that are basic plane figures. So to find, basically you can split them up into different shapes. To find the area of a composite figure, we are going to divide our figure up into the regions and find each area. Then we're going to find the sum of all the areas. When we find the area of a shaded region, oh, this is the same thing. Yours is fixed, but mine's not. All right, so let's get started. In number 20, we have a half a circle with a radius of 6, and we have another half of a circle that also has a radius of 6. So we have one full circle with a radius of 6, and then we have a parallelogram here with a base of 6 plus 6, which is 12, and a height of 5. So I'm going to find the area of the circle by doing pi times 6 squared. And that's going to be 36 pi, which is approximately, if we do 36 times pi on our calculator, we would get about 113.10. And then doing the area of the parallelogram, which my base is 12 and my height is 5. 12 times a 5 is a 60. So then we're going to add these two areas together to find the area of the total, which is approximately 173.1 inches squared. All right, number 21. I have half of a circle with a radius of 8, and then I have an isosceles triangle. If I find the height of that isosceles triangle, that's going to be this blue line here. The base is 16. To find the height, I'd use this pink right triangle, which actually is a Pythagorean triple. This is an 8, 15, 17 triangle. And so that's my height. So let's look at the semicircle first. The area would be 1/2 times pi times 8 squared. So that comes out to be a 64 times a 1/2 is a 32. So a 32 pi, which if I use my calculator, a 32 times a pi rounded to the nearest hundredth is about 100.53. And then for the triangle, it's 1/2 my base, which is 16, times my height, which is 15. So a 16 times a 15 is a 240, times a 1/2 is a 120. And then if I add these two together, I would wind up with my area being approximately equal to 220.53 meters squared. Okay, for my next problem here, I have a rectangle and a trapezoid. So my rectangle has a height of 12 and a base of 23. My trapezoid has a base of 23, my other base is 15, and my height would be 18 minus 12, which is a 6. So let's find the area of the rectangle first. That's going to be a 23 times a 12. 23 times a 12 comes out to be a 276. And we find the area of the trapezoid, which is going to be a 1/2 times the height of 6 times the sum of my two bases. So a 15 plus a 23 times a 6 times a 1/2 comes out to be a 114. And then adding those two together, my area comes out to be 390 centimeters squared. All right, number 23, I have 3 shapes this time. So one of my shapes is a semicircle with a radius of 9. Let's go ahead and find the area there first. So area is equal to 1/2 pi r squared. So a 9 squared is an 81. And then times a 1/2. And then times a pi, rounded to the nearest hundredth, I get approximately 127.23. Then I have a rectangle that has a base of 9. And then if I do 26 minus the radius of my semicircle, which is 9, I would get the height of my rectangle, which is 17. So for the area of my rectangle, it would be a 17 times a 9, which comes out to a 153. All right, so for the next part, if I do 17 minus this little portion, which is 7, I'm left with this leg on my right triangle here as 10. And this is the same as the radius of my circle, which is 9. So my right triangle, my base and my height are 9 and 10. So doing the area of the right triangle, I have 1/2 times a 10 times a 9, which winds up giving me a 45 for the area of the triangle. So then to find the total area, I'm going to add up all 3 of these areas. And my area is going to be an approximate because I had to round the semicircle. But when I add all 3 of these up, I wind up with 325.23 feet squared. All right, looking at my next one here. So for this one, I have a trapezoid, I have a triangle, I have a square. So what I'm going to have to do first is I'm going to have to use this height on my triangle and this hypotenuse on my right triangle to help me find this, which I'm going to label as x. So how I'm going to use that is I'm going to use the Pythagorean theorem. So I have an x squared plus a 9.6 squared is equal to a 12 squared. So an x squared plus a 9.6 squared comes out to be a 92.16, and a 12 squared is a 144. So I'm going to subtract that 92.16 from both sides to get an x squared is equal to a 51.84. Taking the square root of both sides, I wind up with x being 7.2. Now this helps because if I multiply that by 2, that gives me the base of the triangle, and it also gives me the length of my square. So the length of my square and the base of the triangle are 14.4. So I now have enough information to find the areas of all 3 of these figures. Since this is a square, this is also 14.4. And my height of my trapezoid then is going to be that 25.4 minus the length of my square, which is 14.4. So the length of my trapezoid is 11. So let's get started on finding the areas of all these. Let's start with the triangle. So my area of my triangle is 1/2 times my base of 14.4 times my height of 9.6. So a 14.4 times a 9.6 times a 1/2 comes out to be a 69.12. Okay, to find the length of my square, that's going to be a 14.4 times a 14.4. Which is a 207.36. And then lastly, my trapezoid is going to be a 1/2 times the height of 11 times my 1 base of 10 plus my 1 base of 14.4. And so a 14.4 plus a 10 times an 11 divided by 2, or times 1/2, is a 134.2. Adding all of these together, I get my total area, which comes out to be 410.68 meters squared. All right, moving on to my next page. This time I'm finding the area of the shaded regions. So it might be helpful to find the area of the whole thing and then subtract the white portion. So that's what we're actually going to do in number 25. I have a rectangle, and the area of a rectangle is the base times the height, so 14 times 25, which is going to come out to be 350. And then I have a triangle with base 25 and height 11. So 1/2 the 25 times the 11, which comes out to be 137.5. And now I'm going to subtract the 2 to get my whole area, which comes out to 212.5 centimeters squared. All right, on my next one here, I'm going to need to use this right triangle to help me find this diameter of my half circle. So I'm going to use the Pythagorean theorem to do that. So I'm going to set that up. I'm going to have you pause the video and you're going to finish off the Pythagorean theorem on your own. So then if I find the area of the semicircle, that's going to be 1/2 times pi times my radius squared. If my diameter is 23.4, my radius is 11.7. And then for the triangle, that's going to be 1/2 times my base of 9 times my height of 21.6. And then we're going to subtract those two areas. I'm going to have you pause the video and finish this one off. Okay, so you wind up with this answer. I'm going to have you guys try these next two completely on your own. Pause the video and then replay it or restart it to figure or to show the answers. Okay, and these end up becoming your answers. The blue on number 27 represents the area of the square, where the red represents the area of the circle, and we subtract the 2. On 28, the blue represents the area of the trapezoid, the red represents the area of the semicircle, and then we subtract the 2.